Hi everyone, I'm Martin from FluidTech. Today we'll have a video from Dr. Carsten Giebeler, CEO and Managing Director of Spectrolytic. He's going to give us more information about portable oil conditioning monitoring. So he's unavailable, so if you have any questions, please get in touch with him through the LRVS panels. So we won't be having any question and answers at the end of the video, unfortunately. Let me just start the video.
Hello, good afternoon. My name is Carsten Giebeler and I'm the Managing Director of Spectrolytic, where we've developed inline and portable oil analysis systems. And today I'm going to give you a brief overview about our portable systems. For the people that don't know us, we came to the party a couple of years ago in 2021, where we talked about our inline systems. So our inline systems, they're installed directly at the asset, and we use mid-infrared spectroscopy to analyze the oil samples inline. So the big advantage of mid-infrared spectroscopy is exactly the same sort of technology, analytical methods that used in our laboratory to analyze the oil samples, and that allows us to present the data in exactly the same format and in exactly the same accuracy as the end customer gets when they do a conventional an oil lab analysis. So this year, the focus of the presentation is a little bit more on the portable systems. We use exactly the same basic technology. It's just a slightly different use case. What we do here at Spectrolytic is really summarized in this slide here. We try to optimize the existing sort of oil sample taking process, which is still quite manual. So you have a technician to take a sample, then you have to ship it to the lab, and in the lab somebody does the analysis, and then you get a report back, which can take anywhere between a few days here in Europe to months, or if you are further afield. And we try to optimize this by inline and portable solutions. And our claim to fame is really that the data that we provide comes out in exactly the same units, same accuracy as you get from an oil lab report. How do we do it? In principle, like everything is quite simple. We have an emitter that shines light through a sample, and then we have a sensor that detects the light, and we look at the absorption spectrum, and from the absorption spectrum we can then calculate the relevant parameters. One of the many advantages that we have when using mid-infrared spectroscopy is that we can calibrate our sensor based on historic data. So nobody has to send oil samples anymore to create a calibration file. We can just simply do it based on historic oil reference analysis data. The only thing we need is 5 to 7 FTIR spectra and reference analysis of a given oil sample, and we can use this to calibrate the sensor. So this is obviously an enormous time saving, because availability of samples is always very challenging. Big question always, does it work? Here is a comparison between our sensor result and the lab analysis data from Exxon, who we did quite a lot of work with. And you can see here an example of a gas engine, two parameters in this case, the oxidation and TBN, but lots more parameters are possible. There's a general thing that you always observe. The trends are always sort of correct. The oxidation goes up over time, TBN goes down over time. But what you see is that, call it the standard deviation of the data in our system, is a lot lossless. A typical example is here, the oxidation between 17 and 1800 hours. the oxidation just can't drop down to nearly 10 and then jump up down to 18 without anybody doing anything to the oil. So this is clearly somewhere along the line was a mistake. Either it's a sample taking or it's a laboratory, and we actually find this happens quite often. And this adds on quite a lot of additional overhead because somebody has to sort out these samples. Luckily in this case the oxidation went down. If it gone up, panic. And to avoid this, you can really use the sensors that we provide. And the reason that our sensor data are a lot more stable is obviously not that our sensors are better than an FTR system or whatever other fancy toys they have in the lab, but it's simply that you remove all human involvement. For the inline, there's nobody involved. For the at-line or portable, a person still has to take a sample, but in general, it reduces the interaction with human being, and this is helpful. Here are just some examples of the inline sensors. So you can see we have installation really all over the place for all applications, from natural gas engine to marine diesel to gas turbine. And our portable system can be used in exactly the same applications as well. But there are also some other things you can do with a portable, which we will talk about. So here it is. Portable system, it's really small and compact. We operate it in transmission mode, so the user has to take an oil sample, fills it with oil as a flow cell, and then does a measurement, and the data are presented then on the laptop. So we have our own program that analyzes the data, and the data appear on the laptop. And which parameters can we measure? So a summary is shown here. Because we are analyzing the mid-infrared spectra, we can really focus on all of these parameters that you can see here on the right-hand side in the table. And we can configure the sensor for whatever application and oil the end customer has. Please note that not all of these parameters will be measured in parallel. So, for a gas engine where you have a combustion process, you are interested in soot and sulfation, for example. This is pointless in a gear application, for example. So we agree with the customer the relevant parameters and then set up the existing supportable sensor so that existing warning levels based on conventional oil analysis can be reused. So here's a little video on how the sensor works. It's quite self-explanatory. So you connect it to the laptop. You fill the oil sample into the flow cell. You stick the flow cell into the sensor, and you do the measurement. It takes about a minute or two, and then you have a fairly basic GUI, and out comes the data. Look at the unit, the water and base number here in ppm and milligram KOH, and that's it. So the data is then saved on the laptop itself, and you can print out a report, whatever you want. So here are some use cases. This is a use case at a nuclear power plant in China. You can see we delivered 2 systems to them, and this is a typical application. So the customer has a fixed amount of oils. It can be from different suppliers or different types of oil, that's all fine, but it should be a limited number, in this case 8. And then we can set up the systems to measure the required parameters. In this case, the customer only wanted total acid number, total base number, and water. and that works fine. The reason why we needed two systems has to do with the EHC fluid. This was a phosphate ester 5-way EHC. There, the degradation mechanism is obviously completely different, and the oil is completely different to the more conventional oils, and this is why we had to configure a separate system. But all in all, the end customer is really happy with the performance, and it matches their lab analysis result. Another application is a portable system here dedicated to gas engine. So here we set up a portable system to focus on the Pegasus gas engine oil range from Exxon. We can configure it for biogas and natural gas engines, and here is a nice summary of all the different parameters that you can get from one measurement. And for this particular oil, so we have all the calibration files available, and it's now out in the field and measuring. The portable system, we also have it set up, let's call it for sort of standard applications like FAME analysis in biodiesel, ethanol in gasoline, and oil in water. So these are standard available products that are available. For FAME, you can see the calibration here on the right-hand side. We can calibrate the FAME blender really to any concentration that the end customer / the legislation requires. Same for ethanol and gasoline. For oil and water, the process is based on an extraction method. We recommend the solvent S316, but it also works with hexane, but it's not such a nice solvent. And we are also able to combine the oil in water measurement with the ability to actually tell you what type of oil it is. So for customer, we then differentiate between turbine oil, gear oil, hydraulic, and engine. And you can see the results here on the right-hand side, where a sample was measured and it turned out to be a turbine oil. So this was a large chemical supplier, and they needed to know not only that they had oil in the water, but they also wanted to know which oil it is to figure out where the leakage is, and to do this as quick as possible. So what's the difference really between our technology and other portable systems? So we approach our sensors really from a point is that we want to have a sensor that can differentiate the different aging mechanisms, and the sensor should be able to quantify the relevant parameter. So when the sensor can do that, you can get sort of meaningful results out of it that the end user can understand and can act upon. So dielectric sensors have been around for quite a while. They are used in quite a lot of applications, but for us, it's really, they are not great because you can't really differentiate the degradation mechanisms. You only measure a dielectric constant, and as you've seen in the previous slide, you had something like 15, 17 degradation mechanisms all going on in parallel, and this is just not possible. And in addition, as soon as you have water in your system, water has a really, really high dielectric constant compared to anything else. It just dominates the signal, and it's very hard to interpret these results. Then there are other solutions that are based on linear filters, grating, or FTR-based solutions. So the ideal solution is obviously a portable FTIR. There are quite a few out there, but then you run into problems with the robustness of the systems and the skills required to carry out a measurement. So an FTIR are great systems, but they are quite temperamental and sensitive. You know, you have little moving mirrors in there, and as soon as you drop a system, you know, you can forget it. And so the equipment cost is high, the maintenance costs are also quite prohibitive. So, you know, it works if you have a lab, they are great. For portable systems, questionable. Then you have LVF type scraping-based solution. And, you know, we used to have some of these as well, and they are good as long as the concentrations in the oil that you want to measure are fairly high, because these systems, they have relatively low signal to noise ratios, and also the spectral resolution isn't so great. And so for applications where you focus on, you know, low water, additive concentrations or group 5 oils, these systems really don't work. We also found, and this is obviously only our personal opinion, that this generic approach, you know, get an oil sample on a portable, have some sort of classifier, and then extracting a generic oil analysis from it, that doesn't really work. If you want this, you need an FTIR system and you send it to the lab. For anything else, our opinion is that it doesn't really create reliable data, and this is why we went down the route of really focusing on, you know, providing a system for a specific set of oils as explained earlier. But from a positive point of view, in terms of robustness and ease of use, all these LVF and grading-based systems are very good. So here a little outlook for what's going to happen next year if we are back invited. So here is the first prototype of our FluidInspectIR lab that you can see here. Here we combine really the oil conditioning sensor that we have with additional parameters like a viscosity sensor and optionally optical particle count and wear particle to really provide a customer a reliable mini lab, let's call it like this, that produces lab equivalent data. But hopefully we get the opportunity to talk about this next year. So thank you very much, and if you have any questions, I'm happy to answer it now. Thank you very much. Good afternoon, my name is Carsten Giebeler.
Thank you everyone for joining. Again, so please contact, we have the panels where you can contact. There will be no possibility of doing any answers to any questions because he's not there to do it. So thank you again for your time, and I'll be ending now the session. Thank you very much.